So this is the first assignment of first chapter. Calculate percentage of oxygen in copper sulfate pentahydrate. Now, copper sulfate pentahydrate. Now, when I calculate molecular weight, copper will be 63.5, sulfur will be 32, oxygen 4 plus 5, 9 oxygen atom into 16. Then there will be 10 hydrogen atoms, 10 into 1. If I add, molecular weight will come out to 249.5. This is the molecular weight. Now, in this molecular weight, contribution of oxygen is 9 into 16, that is 144. So percentage of oxygen will be 144 divided by molecular weight 249.5 into 100. This is the percentage of oxygen in copper sulfate pentahydrate. Similarly, second part, this is lead phosphate. Now, in this case, you'll first calculate molecular weight. Will not waste time on calculation of molecular weight. You should be able to do that. So molecular weight of this compound will come out to 811. And this has, we have to calculate phosphorus. Now, this one molecule contains 2 phosphorus atoms. 2 phosphorus atoms will contribute 31 into 2 towards molecular weight. So percent of phosphorus will be 31 into 2 divided by molecular weight into 100. This will be the percentage of phosphorus in the given compound. Second numerical. Naturally occurring boron is a mixture of two isotopes whose atomic weights are 10.01 and 11.01. Atomic weight of boron is average. This average atomic weight of boron is 10.81. Calculate the percentage of each isotope in natural boron. C. Say atoms are 100. Say boron 10.01 atoms are X. Therefore, boron 11.01 atoms will be 100 minus X. Now we'll use the formula the way I told you how to calculate average molecular atomic weight. Average atomic weight is 10.81. That will be equal to X into 10.1, 10.01 plus 100 minus X into this, that is 11.01 into 100 minus X, and divided by total number of atoms, we assumed 100. Now from this, calculate the value of X. This X will come out to, according to the answer only I'm saying, this will come out to 20. It means out of 100 atoms, 20 atoms are 10.01 isotope. It means this is the percentage of first isotope. Percentage of second isotope will be 100 minus 20, that is 80%. Third numerical. How many moles of ammonia will weigh 59.5 grams? See, never expect such simple numericals. Just the beginning of chemistry, I should say, in 11th standard. That's why you are facing this type of simple numericals. Number of moles will be weight divided by molecular weight. Ammonia is a compound. Compound will have molecules. For molecules, we'll use molecular weight. So weight divided by molecular weight, this is the number of moles of ammonia. Fourth, calculate the number of molecules in so many grams of nitrogen. Now see, calculate the number of atoms. There was one formula involving number of particles, and that was number of particles in this case are atoms. So number of atoms divided by Avogadro's number. We are given so many grams of nitrogen. So this second formula will use weight divided by atomic or molecular weight. But the thing is, what do we use, atomic weight or molecular weight? See, we have to calculate number of atoms. Therefore, we use atomic weight. So the weight given is 2.8 into 10 to the power minus 5 gram divided by atomic weight of nitrogen. You are supposed to remember atomic weights of some simple elements. Nitrogen is one of them, and the atomic weight is 14. This numerator will be the answer. You know the value of Na. Na is 6.022 into 10 to the power 23. Next numerical. Number 5. Calculate the number of atoms in so many milligrams of oxygen. Again, similar numerical. Number of atoms you have to calculate divided by Avogadro's number. We are given mass of oxygen.
Sir. In the fourth numerical, they have asked us to find the number of molecules, not the number of atoms.
Sorry. That was number of molecules. That's my mistake. So it should be 2.8 into 10 to the power minus 5 divided by molecular weight. Since we have to calculate number of molecules, so we'll divide by molecular weight, that is 28. That was my mistake. Please correct that. Fifth, now we have to calculate number of atoms. So in this case, weight 3.2 into 10 to the power minus 9, 3.2 into 10 to the power minus 9. We are given milligrams. We'll convert milligrams into grams. So divide by 1000. Odd number of atoms will use atomic weight. And this is oxygen. Atomic weight of oxygen is 16. You'll get the answer. Again, the numerator. Number 6. Calculate the mass of 122 molecules of ammonia. We are given number, so many molecules. So again, one part that we use will be this. Ammonia is a compound, and compound will have molecules. So this will be number of molecules divided by Avogadro's number. And we have to calculate the mass. So this will be weight divided by molecular weight, because ammonia is a compound will have molecular weight. Number of molecules were given 122. Avogadro's number is 6.022 into 10 to the power 23. Weight we have to calculate. Molecular weight of this ammonia. Molecular weight of ammonia is 17. So W will be the answer. Next.
No, but sir, no weight is given. No weight is given.
We have to calculate the mass of.
Oh, okay. Thank you, sir.
Right. Next, 7th. Calculate the mass of so many atoms of chlorine, but to confuse, you are given molecular weight of chlorine. Let us see. Calculate the mass of so many atoms. Number. So number of atoms divided by Avogadro's number is equal to, we have to calculate mass, and we are given molecular weight of Cl2. If molecular weight of Cl2 is 71, naturally atomic weight will be half of 71, that is 35.5. Now, number of atoms we are given 18.066 into 10 to the power 14. Na is 6.022 into 10 to the power 23. Weight we have to calculate divided by atomic weight. This numerator W will be the answer. Next, 8th. How many moles of oxygen atoms are there in so many molecules of ozone? We are given molecules of ozone, but we have to calculate number of atoms of oxygen. See. We are given number of molecules divided by Avogadro's number. This is number of moles. In we have to calculate how many moles of oxygen atoms are present, not molecules, how many moles of oxygen atoms. So number of molecules will be, number of moles will be number of moles of ozone. So number of moles of ozone will be 3.011 into 10 to the power 21 divided by Avogadro's number 6.022 into 10 to the power 23. When you calculate, number of moles of ozone will come out to 0.005. Now, you can see one molecule of ozone contains 3 oxygen atoms. One molecule of oxygen ozone contains 3 oxygen atoms. It means I can say 1 mole of ozone contains 3 moles of oxygen atoms, right? 1 mole of ozone contains 3 moles of oxygen atoms. So number of moles of oxygen atoms will be number of moles of ozone multiplied by 3. 1005 into 3, so many moles, 0.015, so many moles of oxygen atoms will be present. Next, 9th. Calculate the amount of sulfur, means mass, amount of sulfur in 0.95 kilogram of sulfuric acid. See, we'll calculate molecular weight of sulfuric acid. Sulfuric acid, hydrogen will be 2 into 1, sulfur will be 32, oxygen will be 4 into 16, 64. Molecular weight is 98. Out of 98 grams of sulfuric acid, sulfur is 32. So we can use unit method. 98 grams sulfuric acid contains sulfur is equal to 32 grams. 0.95 kg means 950 grams contains how much that you can calculate. This will be the answer. Last numerical. Calculate the number of oxygen atoms in 4 grams of this compound is ferric sulfate. Molecular weight is given within brackets 400. So number of moles of compound will be weight divided by molecular weight. This compound is 0.01 mole. See, the compound is Fe2 SO4 thrice. According to the formula, one molecule of this compound, one molecule of the compound contains 12 oxygen atoms, right? 12 oxygen atoms. It means I can say so many moles of compound contains this into 12 moles of oxygen atoms. So oxygen atoms will be 0.01 into 12 moles. If you multiply number of moles by Avogadro's number, you convert into number of atoms. So atoms will be 0.01 into 12 into Na. So many atoms. Check again. This is number of moles of oxygen atoms. This is number of atoms of oxygen. Just multiply by Avogadro's number, you'll get the final answer. Now coming to theoretical questions. Classify the following into elements, compounds, and mixtures. Petrol is a mixture of compounds, mixture of hydrocarbons. 22 karat gold. You might have heard of 24 karat gold. 24 karat gold is pure. 22 karat gold is a mixture. In fact, it's a homogeneous mixture. You can even call it a solution, homogeneous mixture. But anyways, you can write mixture. Zinc is an element. Glucose is a compound, C6H12O6. It's a compound. Steam is a compound. Steam is nothing but water. Then milk. Milk is a mixture. Iodized salt. Salt is a compound. Iodized salt is a mixture. It contains iodine mixed with it. Advika, there's no need for camera. Please switch the camera. Next, tap water. Tap water is a mixture. You never get pure water in the tap. It's a mixture. Diamond is an element. Diamond is basically carbon. Then brass. Brass is an alloy. Alloys are all mixtures, right? Then gunpowder. Gunpowder is an explosive. It is a mixture of sulfur, potassium nitrate, and other compounds. Next, second compound question. What is a mixture? What are homogeneous, heterogeneous? All that you'll find in your notes. Coming to classify the following into homogeneous and heterogeneous mixtures. Wood. Wood is a heterogeneous mixture. Let us say this is a piece of wood. You cut it, view from outer to the inner side towards the center. Composition will not be same throughout. It is a heterogeneous mixture. Tap water. Tap water is homogeneous mixture. Coca-Cola, any soft drink is a homogeneous mixture. Then steel. I was telling just in the previous question also, all alloys are homogeneous mixture. Steel is an alloy. It's a homogeneous mixture. Next question. How will you separate constituents of following mixtures? First mixture contains the sugar, ammonium chloride, and glass powder. First of all, we'll separate out ammonium chloride by the process of sublimation. After ammonium chloride is removed by sublimation, we'll be left with sugar and glass powder. Now, from sugar and glass to sugar and glass powder, we'll add water, stir it. Sugar will dissolve, glass powder will not dissolve. Now, filter. On filtration, residue collected on the filter paper will be glass powder, and filtrate will be solution of sugar and water. Evaporate water, you'll get sugar. So all the three components will be separated. Second mixture is sand, sodium chloride, and iron filings. First of all, with the help of a magnet, remove iron filings. Now we'll be left with a mixture of sand and sodium chloride. Again, we'll use the process of extraction as we use in the first mixture. Add water, stir. Sodium chloride will dissolve, sand will not. Filter. Residue collected on the filter paper will be sand. Filtrate will be solution of sodium chloride and water. Again, evaporate water, sodium chloride will be left behind. Fourth question. Name the process used for refining of petroleum. This, in fact, is the process which everyone, I expect, you know. Anyways, this is fractional distillation. Fractional distillation is the process also called fractionation, used to separate different components of petroleum. What are homoatomic and heteroatomic molecules? I deliberately do not tell what are homoatomic and heteroatomic. I do not dictate in notes. Homo means same, atomic means atom, same type of atoms, like H2, N2, O2, Cl2, Br2. They're O3, P4, S8. These are the molecules which are made up of same type of atoms. Naturally, they'll be called homoatomic molecules. And in case two or more different types of elements, different types of atoms are present in the molecule, they will be called heteroatomic molecules. Remember, all compounds will come in this category. All compounds, water, CO2, sulfuric acid, NaCl, they all are heteroatomic molecules.
So what about hydrocarbons? They are also heteroatomic.
Hydrocarbons, yes. Hydrocarbons are made up of carbon and hydrogen. Minimum 2 elements are present. Hydrocarbons contain 2 elements. Number of atoms doesn't matter. We consider the simplest hydrocarbon, methane. It contains carbon and hydrogen, 2 different types of elements, types of atoms, right? That will be heteroatomic. And in my assignments, towards the end, you'll find sometimes there are some questions in greening. Those questions, green, you'll find answers of those questions directly in your notes. So those questions will not be taking up here. But by chance, if you do not find answer to any one of those questions, you can always call me. Feel free. I'll explain. I'll tell you how to answer those questions. Right?